Hello everyone, very warm welcome again. Today we are going with our third video or lecture on heap data structure, and this will be the last one before we move towards the coding session. Okay, and as you can see, the things that we need to cover, the thing that is left is the heap sort. So before moving forward, if I would say if you have not gone through the previous two videos in this same series, I highly recommend please do that, because the concepts that have been explained in those two videos, we are going to use those in today's one. Okay, and if you have already gone through and are perfectly fine and understood everything that has been explained, then I can tell you that today's video is going to be very easy, because we are already aware of the fundamentals of the concepts. We just have to apply them today. Okay, awesome. So today we are going to do the heap sort on an example array. So let's take any array. Elements 0, 1, 2, 3, 4, 5, 6, 7. Let's put any random numbers: 4, 7, 1, 3, 9, 6, 8, 2. Okay. So before we proceed with heap sort, as an overview, I should tell that it is a two-step process. Okay. In the first step, we need to create the heap from the array. Okay, as you can see right now, this is not a heap. If you want to draw this, it would come something like 4, 7, 1, 3, 9, 6, 8, and 2. So right now this is not a heap. It is not following the property of min heap or max heap. It's just a representation as of now of the array. So the first step is to create the heap. You can create any of the heap. You can create max heap, or you can create min heap. So it depends on which type of sorting you want. If you want sorting in ascending order, then you have to create max heap. If you have to create the heap in descending order, then you have to create the min heap. So it's reverse. In max heap, the highest is at the top, but it will give us the result in ascending order. Okay, so just keep this in mind. And once we are done with the heap sort, as a second step, we will swap root with last element. If you remember, we did this in priority queue example as well. We swap the root with the last element. Then we will ignore last element, and then we will just do a sync operation. Do sync operation of the root. So when we will just go through the example, you will get the intuition behind why we are doing this. Okay, so as a first step, let's create. So as a step one, let's try to create the heap for our example. We are going to create with the max heap. Okay, now how to create the heap if everything is random as of now? Now what we have to do is we have to start from the last element. From the last element we have to start and check for all the sub heaps which are present, whether they are following the heap property or not. So the last element is 2. Here it is 2. Is it following the max heap property? So in step 1, we have to create the heap. So what we will do, start from last element and apply heapify for the subheaps. Okay, so 2 is the only subheap. It is following. Fine. We are done with 2. Similarly, 8, 6, and 9. All are subheaps, single element. So these are also done. So if you want as a optimization, you can start from the mid of the array as well, because the last part of the array will always be in the form of leaves of the tree, which will always be a single element and will satisfy the heap property. Okay, so till now, till 9, we are done. Now we will move to 3. So is the subheap present from 3 with 3 as the root? Is it following the property of max heap? Yes, it is. So 3 is also done. Next is 1. Is 1 following the property of max heap? No. We have to do the swapping here. So what we will do is, with which element we have to replace? 6 or 8? Which one is greater? 8. So replace with 8. So what we will do is, we will replace 8 with 1. And similarly, in the array also, we will replace 8 with 1. Okay, so with this, this second element is also done. Previously it was 1 here, so we have changed it. That's why 8 has came, but second index is also done. Now move to next index, whose value is 7. Is 7 subheap following the property of max heap? No. 9 is greater. What we have to do? We have to replace it. 9 with 7. Similarly, above also, replace 9 with 7. Right? So 7 again is following the property of max heap. That's good. Let's move to the next index. 4. Is 4 following the property of max heap, the entire subheap at 4? No, it is not. Again, we have to replace it. So we have to replace with 4, with 8 or 9. 9 is greater. So replace it with 9. So 9 here, 4 here. Now again, we are doing the sync operation. So now we have replaced 4. So is this 4 now following the property of max heap? No. Which we have to replace with? With 7. So 7 need to be replaced to 4. Okay, so now we can say that our heap is done. Now we are able to create the data structure, which we can say is a max heap. Okay, looks like we forgot to change the elements in the array. So don't worry, we can change now. This will be 9, this will be 7, and this will be 4, I guess. 9, 7, 4. 4. Right? So till this point, we have done our first step, which says that our first step is done. We are able to create a heap from the array, and we have created the max heap. As you can see, this is a max heap. Now the next point is we will keep on swapping the root and keep on doing the sync operation. Let's see how that works. So what I will do, I will copy this image below. So let's draw this tree again. So it would be 9, 7, 8, 3, 4, 2, and this will be 6 and 1. And let's draw the array as well. Okay. 9, 7, 8, 3, 4, 6, 1 and 2. Index will be 0, 1, 2, 3, 4, 5, 6 and 7. Okay, so exactly we have copied. Now let's begin our second step from here. So as I mentioned from this, for the second step, step 2, swap root with last element, then ignore last element, okay, and apply sync operation on new root. So these steps, 3 steps we are going to follow as a part of step 2. Okay. Now let's see in this action. So what we have to do, what is the last element is 2. Okay. And root is 9. So we have to swap these 2 elements. Okay. So we are going to do this. Two will be here, 9 will be here. First step is done. We have done the swapping. Let's replace in the array as well. This will be 9. This will be 2. Okay. Next step says ignore the last element. When you say ignore, don't consider that it is present in the array. So I will just draw a boundary here that we have to stop at here. Okay, and here also it's a boundary that I have drawn that we have to stop it here. Now you have got an intuition that why we have chosen max heap for ascending order. You can see that the highest element is already at its final position. Are you getting it? Okay, now we have done step 2. We have ignored the last element. And now we will apply the sync on the new root. What is the new root? 2. Okay, is it following the property? No. Let's apply sync. So we have to replace it with 7 or 8. Okay, great, 8. So 8 is the new root. 2 will be here. And let's replace 2 with 8 as well. So 8 here. So 8 here and 2 here. Again, the sub heap at this part, we have to apply the sync operation till the bottom. Okay, is it following? No. Let's replace 2 with 6 because 6 is greater. 6 here, 2 here. So replace 2 with 6. 6 here, 2 here. Sync operation done. One step done. We have, after one step, we have one element which is present at its correct position, right? So when we can say that once these 3 steps are done, after each step, after 3 sub steps are completed, one element will come at its final position. Let's continue, and now we will go a bit faster. Okay, so this swapping we can remove. Okay. Now we have to replace 8 with the last element. What is the last element now? So remember, we have ignored the last part. The seventh is ignored. Okay, so now the last element is 1. So let's swap it with 1. So 8 will be here and 1 will be here. Now ignore the last part. So okay, we have to do the swapping at the array side as well. So 8 will be here, 1 will be here. Okay, now ignore the last part, this part. We will see in code how to ignore that. So we have to just make sure our loop runs one one less, right? One number less to ignore that. So that will be easy. We will see how that is done in the code. Okay. Okay. So we have swapped 1 and 8, ignored the 8. It is also at the final position, and apply the sync on new root. So apply the sync on new root. We have to replace 1 with 7 because 7 is greater than 6. 7 here, 1 here. So let's replace that here as well. 7 here, 1 here. So apply the sub heap on this part. And why I'm not including 9? Because we have ignored the 9 from our heapify process, right? So when we will apply on 3 and 4, so we can say that it will be replaced, 1 will be replaced with 4, 1 here, 1 will be replaced with 4, 4 here, 1 here. Sync operation completed. Now we have 8 in our final step. Okay, 8 is at its final position. What's next? 2. Okay, so what we will do is, now I'm not going to explain, I will keep on doing it a bit faster. So what I will do is, I will swap 7 and 2 because 2 is at the last. 7 and 2 I need to swap. So 7 will be here, 2 will be here, 7 here, 2 here, ignored 7, ignore 7, right? So this is 7. What is the third step? Okay, sync operation. We have to sync operation between 2 and 6. So 6 here, 2 here, 2 and 6, 6 here, 2 here. So 2 is the only sub element left because we have ignored 7 and 8. So it is already at the correct position. Nothing to be done for it. We are done. What is the next element that we have to swap is 6 and 1. So let's do that quickly. 6 and 1. 6 here, 1 here, 6 here, 1 here. Swapping we have done. Ignore 6. Ignore 6. What's next? Do the syncing, right? So let's perform syncing of 1. It has to be done with 4, right? 1 and 4 will be swapped. So 1 here, 4 here, 4, 1. Again, 1 and 3 we need to swap again. 1 here, 3 here, 1, 3, we need to swap. We are done. What's next? 4 and 1 we have to swap. Okay, so these are the two that we need to swap now. Okay, what we will do, we will swap 1 and 4. 4 here, 1 here, 4 here, sorry, 1 here, 4 here. Ignore 4 because it is at its final position. Ignore it, don't consider it. Now you have to apply the sync on 1. Whom to replace with? We have to replace with 3. 3 here, 1 here, in array also. 3 here, 1 here. Now where we have to replace 3 with? 2. Okay, because this is the last element. So what we will do, we will remove this, 3 and 2 we have to swap. So 3 here, 2 here, 2, 3. Ignore 3. Okay, we will ignore 3. Now apply the sync on 2. So only heap that right now left is between 1 and 2. So when we will apply, okay, so now what's next? We have to see apply the heapify on 2 and 1, because it's already a max heap. So we won't do anything. No need to perform any operation during our sync process. So now what have to do? Again, first process, you have to swap 1 and 2. So doing this, 1 here, 2 here, right? Ignore 2, ignore 2, 2 is ignored, 1 is only left. It is already at the, you can say it is the max heap present because it is the only element. So we are finished our process. So as you can see, when the last element remains, we don't have to do anything because it is the last element. And now we have our array in the sorted order. I hope you got the intuition why creating max heap resulting in ascending order, and why creating the min heap resulting in will, I mean, you can try that at with yourself. If you face any problem, do let me in the comments below. And if you create the min heap, then you will get the descending order. Okay. So with this, we are done with the heap sort. As a first step, you have to create the heap using this process. And once you create the heap, after that you have to perform these 3 steps: swapping of root, and keep on ignoring the element, performing the sync operation. Okay. Next we will going to cover about time complexity. Okay. With this, I would say thanks for watching. We have covered our entire syllabus on heap. This is done. I would say if you have any questions, please do let me in comments below. Okay, thanks for watching. See you. Have a great day. Bye bye.